What is a black hole? Quite simply, a black hole is a region of space where gravity reigns supreme. Nothing, not even light, can escape its intense gravitational pull. They are formed when an object's internal pressure is unable to resist its own gravity. A common misconception is that an object has to be big to become a black hole. This is not entirely true. The density of the mass energy is what triggers black hole formation. For example, if you compress the Earth to the size of a nickel, the Earth would itself become a black hole. The most common way for a black hole to form is during the death of a star. When a star, roughly 20 times the mass of our Sun, uses up all of its fuel, it explodes in spectacular fashion. This explosion is known as a supernova. Supernovae occur when the engine, or furnace, inside of a star runs out of fuel and is no longer able to sustain the internal pressure to fight off gravity. As the star begins to collapse in on itself, the outer layers start to fall inward, then rebound outward violently, producing the explosion. The inner dense core of the star continues to be compressed by gravity. With no fuel left to fight off gravity, the inner core collapses into a black hole. As the transformation takes place, energetic gamma rays are produced at the poles. These short gamma ray bursts are the most luminous electromagnetic events known to occur in the universe and are a telltale sign of a supernova. How big are black holes? Black holes are commonly found in two flavors: stellar mass black holes and supermassive black holes. Black hole merger. Stellar mass black holes are the most abundant, and are formed when a star of sufficient mass dies. The upper limit on size so far discovered for this type is around 33 solar masses. Supermassive black holes, on the other hand, are gigantic. The smallest being hundreds of thousands of solar masses, the majority averaging millions of solar masses, and the largest discovered so far topping out at 18 billion solar masses, roughly the size of an entire galaxy. Each galaxy is thought to contain one at its center. Their growth and formation is a complex process, involving black hole cannibalism, galactic mergers, and gorging on whatever gets near them for billions of years. Can a black hole die? In 1974, Stephen Hawking showed that black holes are not entirely black but emit tiny amounts of thermal radiation. This effect is known as Hawking radiation. Due to this radiation, black holes lose energy, mass, and can evaporate. While an incredibly slow process, it will eventually cause a black hole to die. Though, slow is a bit of an understatement. The process can take trillions of years or more for a black hole to evaporate away. Common misconceptions. One common misconception is that black holes are shaped like funnels. A black hole is similar to a funnel, but that visualization would only be accurate in a two-dimensional universe. Black holes are spherical, which means the funnel would be three-dimensional. Black holes are not much different from regular stars. You just can't see them, and they have stronger gravity. Could a black hole be used to travel? Another misconception is that black holes could be used as a portal to another dimension or can transport you across space and time. This is likely the result of speculation caused by the mathematics of general relativity and quantum mechanics breaking down at the singularity, the core of a black hole. Unfortunately, even if this were true, you wouldn't survive the trip. Just outside and orbiting the black hole's event horizon, the event horizon is the edge of a black hole. The boundary where even light cannot escape its intense gravity is an orbiting ocean of super-hot gases and plasma. Gases so hot, they're hotter than the surface of the sun. Yet, even if you could somehow survive the extreme temperature and radiation, you still have to contend with gravity. The gravitational tidal effects of stellar mass black holes are beyond extreme. These tidal effects rip matter apart down to the quarks that make them up. You'd be atomized before you could reach the singularity.